Hi, welcome back to this session. I'm going to explain about context in Golang. Probably I'm not going to explain about in one video. I'm not going to explain about everything about context, but context is one of the most perplexed concept in Go language. Generally, we find difficult in using context. It's a kind of a tricky implementation generally whenever we go and use context. So just to have an overview about context. Generally, context is something that a set of or group of statements that are executed across application boundaries, application or API boundaries. Generally, we call it as a context. Generally, it's a one kind of a work, certain work, we call it as a context. There is a package in Golang which is called a context package that facilitates the different operations that you we perform with context, something like canceling a context. Once a context is cancelled, it propagates to it's a child context as well. That means context has got a parent context, and then context also has a child context, one or more child contexts. Once a context is cancelled, it is propagated across application boundaries or API boundaries. Generally we call it as wherever the context is used, right? So particularly context is very important whenever we are implementing uh, systems with the concurrent or asynchronous operations running. Concurrent operations or asynchronous operations in Go language are generally Go routines. So whenever we are running asynchronous operations or concurrent operations, something like Go routines, then we can use context to cancel that particular Go routines. Let's go with a I will show you, I'll explain you with a simple example. Then you will understand actually how to cancel the context and then what will happen when a context is cancelled. So let's go to the demo. So go mod init demo. This is going to be a demo module, code main.go, package main, function main. First, what I do is I create a function called generate numbers, generate squares basically, uh, which is a Go routine. And then once the values are generated, so that Go routine, it returns the values through a channel. So you know that it's a generator pattern. Whenever you are using Go routines, you can use this generator pattern that Go routines return the values through a channel. Simple thing is function generate squares, and then it's going to return the values as a channel. So I create a channel. It's unbuffered channel, and then I return this channel. Inside here, I'm going to return the channel. So I'm going to run it as a separate Go routine because this operation should happen concurrently. For I equal to 1, I less than or equal to 10, for example, I plus plus. So ch equal to ch is sending a value to the channel I into I. Once the 10 times the iteration is finished, then I would like to close the channel. So this is a general channel implementation, this particular generator. So it's a loop for 10 times, and then every time the I value is squared. I'm sorry, not I into I value is squared, and then I into I, and then it is sent to channel. The channel is returned. After 10 times it sends a value, the channel is getting closed. We are closing the channel. So channel is generate sequence SQ. That means a channel I have created that's going to generate the squares. It's a channel, and then I want to retrieve values from the channel. So sorry. So for simple range loop across channel, So a value is generated, that is called getting a value, fetching a value from a channel, and then that value is returned to val, and then I'm going to print the value. So there is no context implementation over here, but I will show you the context implementation in a while. Go run main.go. You see that 100 values, I mean 10 values, 1 into 1 is 1, 2 into 2 is 4, and so on. 10 into 10 is 100. So the values are generated inside a channel, and then values are sent uh, through the channel. There is a receiver that's going to receive all the values using a range loop on a channel. So this is pretty straightforward implementation, and then many of us well aware of this kind of implementation. Returning a channel is very common scenarios whenever you are using channels in Golang. Now, I would like to implement a context rather than sending values. I mean, iterating for 10 times. I would like to iterate it for uh, a millisecond. So I want to give it as a timeout or a deadline for a millisecond, and then for a millisecond, I would like to generates the values. So once it is beyond millisecond, if it is timed out, immediately I would like to return from the channel. I would like to close the channel and then return from the function. That's what I would like to do. So first thing is we have to create a context, and then it also gives a cancel function, context dot with timeout. So there are three functions with cancel means manually you can cancel. Whenever you want to cancel it, you have to invoke the function called cancel. The other thing is deadline. Uh, Deadline is something like you were telling that from now onwards in the future, after 1 millisecond or 10 seconds or whatever the time duration, you say that it's a deadline. I would like to give a deadline to the context. And the other one is called timeout. So deadline or timeout are analogous. It's precisely for the naming convention purpose actually. Timeout also internally uses deadline. So we can use either deadline or timeout. So I'm going to use timeout. Time dot, it's a duration you have to pass. First thing is the parent context. So we do not have any parent context right now. So CTX, you can directly call it as context dot background, and then time dot millisecond into 1. So what happened is this is a parent context. Generally, if the parent context is created over here and then passed across application boundaries, so assume that this is a context I have created, and then it comes with a cancel function and then a child context. And this function, this particular generate SQ should be able to accept a context as a parameter. So here I'm going to pass it as a context as a parameter. This is going to be context. And even though we manually don't call cancel function, it is always pretty good practice because this particular context gets cancelled automatically after a millisecond. So defer cancel, it's always a good call to ensure that the propagation happens and then everything gets cancelled. So it's always good to call the cancel function even though we are using timeout or deadline context. Now I pass context here as a parameter, and then I passed a context as an argument. For example, after a millisecond, since the context lifetime is for a millisecond, after millisecond, 1 millisecond, it gets timed out. I don't want a loop like this because it's all based out of bits. It's all based on a time. So we have something called select in Go language. Select is similar to switch, but select is precisely used for channels. So whenever a context is cancelled with a deadline or with a timeout or even manually, so there is a channel. That channel is generally we call it as a done. Done is a channel. So that done channel is invoked with a status called closed. Done channel is invoked with a status called closed. You know that even when a channel is closed, it sends a signal to the select block. So as soon as the channel is it's a timed out, the context is timed out, I would like to send it, I would like to receive a value from the channel, context dot done. As soon as I receive the value, I would like to close the channel and then I would like to return from the function. If not, which is a default case, I would like to send values to the channel. Where is I? There is no I, so I put I as 1 and then I would like to say I++. So here the implementation is it's not depending on I. So the channel gets cancelled, the channel gets closed. So as soon as it receives a timeout signal from the context, that's what it does. As soon as it receives a timeout signal from the context, so I'm going to run this particular application. Go run main.go. You see that. So after a few numbers, the channel was, after a millisecond, the channel is automatically timed out. This is what about timed out. Of course, you can also create with a deadline, the same implementation, context cancel. You can say context dot with deadline, uh, context dot background, and then it's a time. So here it is a duration generally, and then here we have to pass a time. Uh, time dot now dot add of time dot millisecond into 1 minute, time dot millisecond into 1. So this is with the deadline. So as I said earlier, both of them are analogous to each other. Sorry, I put it as a microsecond. It is supposed to be millisecond. You see that after a millisecond it got cancelled. So to summarize, this is how you can call a context with a deadline or timeout. So it's a good practice to defer. So generate squares is a function. It generates squares until it reaches the deadline. As soon as it reaches a deadline, I'm closing the channel and then returning from this particular function, this function. This is how you can also cancel or notify go routines based on a context. So generally there is no way that you can cancel a go routine. There is only go runtime. Runtime dot go exit is there, uh, but based on, it's not based on propagation of parent or child context. It is one go routine you can go and call. But this particular application, what you're gonna do is you create a context and then as soon as the context is timed out or it reaches the deadline, you are going to cancel another go routine in that particular context. This is what about how you can execute channels and then how you can utilize context in order to cancel particular go routine. Yeah, thank you very much for this. Thank you.